How's it going?
It's just not turning out the way that it should. I think we need better equipment.
Let's call Todd. What do you think, Scully? Horns or no horns? Horns. Oh, hey, it's Mr. Maddox. Sturge, what are you doing? I'm fitting my skeleton for a new skull. I'm thinking I'm going with horns today. Hey, so Rachel and I are over here in the chem lab just tinkering about, and we're doing some mad science, but we don't have the equipment we need. So I was thinking about going over to Edinburgh. Edinburgh? Where's that? That's a city in Scotland, but never mind that. What I meant to say was let's go over to the university where they've got a state-of-the-art chem lab. Got it. That sounds good. You have connections over there? I can find our way in. I like the sound of that. I'll be right over.
All right, as you can see, we are back in Mrs. Barzak's car again. Mr. Maddox driving. I've got shotgun, Mrs. Barzak in the back. Mrs. Barzak handed me these glasses and said, let's go over to the university. Mr. Maddox, what's the plan today? Safety first.
I'm not real sure. I've had contact with one of the chemistry professors over here, and he promised us a magic show and maybe a little tour of some of the equipment that they've got. So I'm excited to see what they have to offer.
All right, guys, more when we get there. All right, science team's assembled. We're walking into Cooper Hall. It did not look like this when we went here. Here's the thing, kids. When you leave school, they use the money you pay them to make nicer buildings. All right, Mr. Maddox, this is how we start off every show. What are we doing?
Materials.
I graduated from Edinburgh University way back, a long time ago, and spent a lot of time on the chem floor. Even though I was a biology major, I spent a lot of time on the chem floor doing chem labs, and I got to know several of the professors very, very well. So I reached out to one of them, a Dr. Unico, and she introduced me to a Dr. Armitas. And so he agreed to bring us in and do a magic show for us, and kind of show us
They're illusions.
Now you see me? Now I'm a magic man. See a magic show today. He's going to take us on a tour of some of the facility and show us some of the instrumentation for us so that you guys can get a sense of what is possible inside these walls and what's possible if you choose to pursue a field in science, particularly chemistry.
Well, and hopefully you can, 8th graders, bring in some of the information that we just talked about this year and realize that you have learned some chemistry.
Salts, ionic bonds, covalent bonds, those sorts of things.
Safety first. Mr. Maddox, where do these stairs go?
All right, yeah, so we're here at Edinburgh University in Cooper Hall, and this is Dr. Armitas, and he was so graceful to, gracious. He was so gracious to allow us to come here and put on a magic show for us today. And so if you would, please just kind of like talk to him about your path to becoming a chemistry professor.
Sure. So I'm a chemistry professor here at Edinburgh. Again, my name is Dr. Armitas. I'm an inorganic chemist. That means absolutely nothing to you, but it does in the chemistry world. I went to college for chemistry because I had an excellent high school chemistry teacher, believe it or not. So that kind of led me down the path of going into chemistry. And I started taking chemistry classes. I was good at math, and I really enjoyed discovering things and nature and the chemical world. I wanted a set of beakers and chemicals when I was a kid and a microscope. And so I started taking chemistry in college. And then my senior year, I had an excellent chemistry professor. He was an inorganic chemistry professor, and that sent me off to chemistry graduate school. So I've just had some excellent teachers along the way, and I kind of wanted to pay it forward and do the same thing at some point to really push my students to become chemists.
So that's awesome that you were able to pursue that, and now you are here at the university teaching. But if somebody doesn't want to go into teaching, is there a field for them involving chemistry outside the walls of the university?
No, absolutely. So we have sent kids a number of places, and I had explored a number of places as well. There's a handful of different places you can go. If you don't want to teach, whether at the high school level, middle school level, or at the college level, we have a bunch of people who would go off to medicine. So they're going to be doctors, or not every single doctor that is out there is doing surgery or doing medicine. We have a bunch of doctors who go into medical research, so they're working with medical schools and a bunch of other institutions as well. So you can actually work as a doctor, but actually doing chemical research or biological research. So we send a lot of students off to medical school. We also send students to into the chemical industry. So they're working for pharmaceutical companies or drug companies. They're working for farms and those types of things, agricultural companies. So there's a large gamut of people that we're sending off. So anywhere from foods, like looking at flavor profiles, or looking at flavor profiles, or learning how to mix together things to keep them stable. So the stuff that you pull off the shelf, if you've got a juice box or a Coke or something like that, the reason that it can stay on the shelf so long is because of a chemist, knew what preservatives were safe for you, and we're going to keep it there for a while. So, food chemistry, industrial chemistry, which is, making materials like, laptops and laptop batteries and those types of things. So chemists run the gamut of every single thing that you touch, and the chemist has probably had some influence on it.
How tall are you?
I'm 6'8". Yeah.
I'm not that short, people.
Chemists are generally very, very tall and thin, I guess. I don't know. Yeah, no, I'm 6'8".
All right, so if you would, let's show us around the chem labs, and show us what kind of instrumentation.
Sure, yeah, and I'll actually also show you guys a chemistry magic show at the end. So.
All right, perfect.
Perfect, let's get to it. So, I'm going to tell you this is yours. So shake, you're going to got the two in the back. You're going to mix them in the beaker, okay? And then you're going to, once you mix those in the beaker, then you're going to pour them into the flask, and then you're going to pour that in, and then you're just going to start shaking. You're going to want to watch what's going on. You're going to see some stuff happen as it goes, if it works properly, as it should. So you're going to see some stuff happen. So everyone in their spot. All right, so this is me. All right, here we go.
Okay.
All right, so shake this.
Shake again.
All right, these two, this is ammonium nitrate and silver nitrate. We're going to mix them together. Put those out of the way. All right, shake again. So when we seal this up, we want to shake a lot. All right, so beaker, add it in, and then the base, which is you can see a color, and shake. Yep, add that in. Oh, yeah, mix this in there. Pour that in, and shake. Now look, stop and look. Do you see anything happening? Not really. Shake away. Stop and check it. Anything happening? Nope. Just keep going.
Like a titration.
Stop and look. Anything?
Nope.
Okay. Stop and look. What's happening? Starting to get darker, yeah?
Mm-hmm.
Perfect. Darker?
Mm-hmm.
You could just keep shaking, keep shaking, keep shaking, keep shaking. Just one of us has to stop and show.
The whole plastic gets darker.
Oh!
So what's going on, Mr. Maddox? What do you got happening?
Not really sure.
Look at that.
This is a tolerance test. This is the reduction of silver. So it started as just the silver ion, and it's dissolved in water. And over time, it actually turns into
Look at that.
solid silver.
Oh,
so
that's
keep
sweet.
shaking.
Man.
Keep shaking. And then when it's nice and finished, you're gonna see a really, there you go. Look at yours. Perfect.
Ho, ho,
See?
ho, ho.
Look at that.
He promised us a magic show, and he delivered.
All right. So once you think yours is done, once you like the silver color that it is Here, you're gonna keep shaking mine. You like that? All right. So this is silver. Everything in here.
Oh,
these
yes.
are some pretty terrible nitrates. This actually would be explosive. So we're gonna rinse this. We're gonna open it up, and I'm gonna rinse this out. Rinse it out, and that's that. So if I seal this up and I keep this sealed, that will remain silver. So there you go.
Hence the
The
silver
silvered flask. All right, that's it. The silvered flask.
Yay.
So I'll send you guys home with one of each of these, but all right. Elephant toothpaste. This is releasing a bunch of oxygen really rapidly. So this is, you could actually ignite this on fire. You won't, but you could. Yeah, it's a bunch of oxygen. So, and the beautiful thing is that this is soap. So it's actually kind of cleaning itself in some ways.
What was in there?
It was a peroxide. It's a 30% peroxide. 30% peroxide is, hairdressers can get it. It's pretty powerful stuff. If you got it in your hands, it kills everything on the surface. The first indicator, it's going to be reddish when it's acidic, and it's going to be purplish when it's basic. And so we kind of see all of the colors of the rainbow when I'm going to put acid on one side and base on the other, and then I'm going to mix it. So this works. So there's a little acid there. You can see that it's red on that side. So you can see at the bottom it's starting to blend the red to the orange to the green. Green means it's completely neutral, it's just water. Base. Purple on the other side. So now close this. Make sure it's sealed up. Mix. Just water and a little bit of acid and base. And if I mix this, it would be one color, but there is a gradient just because it's in a really long water. See that? Alright, so we're about to sacrifice a gummy bear. This is potassium chlorate. I need to melt it. It has a pretty low melting point. This one happens to have a little bit of a low one. So you can see it starting to turn solid, or liquid rather. Alright, here's our gummy bear. So if you listen really closely, you're gonna hear the gummy bear scream. Ready?
I heard it.
That reaction, this is just CO2. It looks, and this is gonna smell, if you get over here, this is gonna smell like burnt sugar, because that's essentially what it is. So, yeah.
Mr. Maddox, what do you think about the gummy bear?
Poor gummy bear.
Is Barsky okay?
I think that was perfect. That's what should happen to gummy bears.
These are all metals. And if you want to film this is totally worth doing with your cell phones. So these metals, this is called the metal rainbow. So these metals will essentially, what's going to happen is I'm going to ignite these. And when I ignite these, they're going to excite. And you have a rainbow of colors. So the red is strontium. The one of the oranges is potassium. The other one is sodium. The yellowish one is sodium. The green one is copper. The blue is an ethanol, and the one all the way on the end is a nitrate, I believe. So, yeah. This is the metal rainbow. Yeah. So these are going to burn out once the methanol is gone. And when you're finished with this, remember to always smother fire. I have done one of these demonstrations where I caught myself on fire. I can tell you that story. So yeah, I'll take you to.
Leave this stuff here. We'll come back and grab
Yeah,
it.
we can grab it later. All right. So this is a faculty research lab. So we do research, and our students do research with us. It's something that they can explore outside of classes. So if you come on in, so this is a much smaller version of the other labs that we have for students to learn in. It's just this is a biochemistry lab. So there's a hood and there's a little bit smaller space. So a handful of students, can work in here. Lab. So this is where our students, about 20 students at a time, can work in here, and there's a bunch of hoods set up. So we have students doing chemical work here for their classes. The shared instrument lab. We have a bunch more instruments.
Cow.
So we have infrared spectrophotometers. This is
Get up in there.
I would not get up in there. It's a strong magnetic field. It may mess up your credit cards, your cell phone.
NMR.
This is an NMR. So this is an MRI for molecules. So when people go in to get a scan at a hospital, they put their body in the little MRI machine and they can identify what's going on inside of them. This is the same thing, but for molecules. So I can take a sample and I can put it in there, and this will tell me what's going on within that little solution or what I have present.
So when we started making these videos, one of my main objectives was to explore things that students wouldn't typically have the opportunity to visit. Even in a normal situation in school, it's very, very difficult to bring a group of students over here and see what we saw today. So we want to take you outside the walls of the traditional school building and into places that are going to open your eyes to new things, and I think that happened today. I think this was a good experience. There was a lot of things that were familiar to me, having been a student here and doing some of those same labs. But Mr. Sturgis, you had kind of a different background educationally. Tell us what your thoughts are.
So my thoughts were, first off, like my mind's blown. Some of that stuff was really cool. And then the science part of my head kicks in is because I don't know the chemical part of this, the chemistry. And my head starts going like, so why were those different colors the way they were? Those are the questions I had. Like what really happened inside that bottle that turned it silver? Like elephant toothpaste, what? Why? So my head starts going. So I've got some questions, and I'll just be probably on the Google machine trying to figure out.
I think really this is the difference between the person who's at home in the kitchen following a recipe and the chef that's in the kitchen who's creating new foods that just, the flavor is explosive. As a student going through here, you're learning the material and you're following a recipe and you're doing these labs to see different things. But somebody like Dr. Armitas, he's a chef in the kitchen, and he has the knowledge of how to blend flavors and sweet and hot and all of those things. And when you have that knowledge of how chemicals work and why, then you're able to go outside of the recipe and explore and research and do new and fascinating things.
So how about you, Mrs. Barzik? How does this match up with your schooling, what you teach?
Well, I was a biology major, so I, had to take chemistry. It was a long time ago. I never had a chemistry professor like Mr. Armitas. They were very dry. They didn't want to put on a show. So that would have been very interesting to me as a college student, and I'm thankful that they have a professor like Dr. Armitas here, and many of them that are all, willing to get students involved and excited about chemistry. And I hope that those of you that are in 8th grade are making those connections between what we have talked about so far in chemistry and what Dr. Armitas talked about in the lab.
That's it. It's a weird echo.